The Soroban is an abacus developed in Japan. It is derived from the Chinese suanpan, imported to Japan in the 14th century. Like the suanpan, the Soroban is still used today, despite the proliferation of practical and affordable pocket electronic calculators. Construction. The Soroban is composed of an odd number of columns or rods, each having beads. One bead having a value of 5, called Godama, and 4 beads each having a value of 1, called Ichidama. Each set of beads of each rod is divided by a bar known as a reckoning bar. The number and size of beads in each rod make a standard-sized 13-rod Soroban much less bulky than a standard-sized suanpan of similar expressive power. The number of rods in a Soroban is always odd and never less than 9. Basic models usually have 13 rods, but the number of rods on practical or standard models often increases to 21, 23, 27 or even 31, thus allowing calculation of more digits or representations of several different numbers at the same time. Each rod represents a digit, and a larger number of rods allows the representation of more digits, either in singular form or during operations. The beads and rods are made of a variety of different materials. Most Soroban made in Japan are made of wood and have wood, metal, rattan, or bamboo rods for the beads to slide on. The beads themselves are usually bicanal. They are normally made of wood, although the beads of some Soroban, especially those made outside Japan, can be marble, stone, or even plastic. The cost of a Soroban can increase depending on the materials. One unique feature that sets the Soroban apart from its Chinese cousin is a dot marking every third rod in a Soroban. These are unit rods, and any one of them is designated to denote the last digit of the whole number part of the calculation answer. Any number that is represented on rods to the right of this designated rod is part of the decimal part of the answer, unless the number is part of a division or multiplication calculation. Unit rods to the left of the designated one also aid in place value by denoting the groups in the number. Suanpan usually do not have this feature. Usage. Representation of numbers. The Soroban uses a decimal system, where each of the rods can represent a single digit from 0 to 9. By moving beads towards the reckoning bar, they are put in the on position, i.e., they assume value. For the 5 bead, this means it is moved downwards, while 1 beads are moved upwards. In this manner, all digits from 0 to 9 can be represented by different configurations of beads, as shown below. These digits can subsequently be used to represent multiple-digit numbers. This is done in the same way as in Western decimal notation. The rightmost digit represents units, the one to the left of it represents tens, etc. The number 8036, for instance, is represented by the following configuration. The Soroban user is free to choose which rod is used for the units. Typically this will be one of the rods marked with a dot. Any digits to the right of the units represent decimals, tenths, hundredths, etc. In order to change 8036 into 80.36, for instance, the user places the digits in such a way that the 0 falls on a rod marked with a dot. Methods of operation. The methods of addition and subtraction on a Soroban are basically the same as the equivalent operations on a suanpan, with basic addition and subtraction making use of a complementary number to add or subtract 10 in carrying over. There are many methods to perform both multiplication and division on a Soroban, especially Chinese methods that came with the importation of the suanpan. The authority in Japan on the Soroban, the Japan Abacus Committee, has recommended so-called standard methods for both multiplication and division, which require only the use of the multiplication table. These methods were chosen for efficiency and speed in calculation, because the Soroban developed through a reduction in the number of beads from 7 to 6, and then to the present 5. These methods can be used on the suanpan as well as on Soroban produced before the 1930s, which have 5 1 beads and 1 5 bead. Modern use. Despite the popularity of calculators, the Soroban is very much in use today. The Japanese Chamber of Commerce and Industry conducts examinations, which Soroban users can take to obtain licenses. There are 6 levels of mastery, starting from 6th grade all the way up to 1st grade. Those obtaining at least a 3rd grade license are qualified to work in public corporations. The Soroban is taught in primary schools as a part of lessons in mathematics because the decimal number system can be demonstrated visually. When teaching the Soroban, teachers give song-like instructions. Primary school students often bring 2 Soroban to class, one with the modern configuration and the one having the older configuration of 1 heavenly bead and 5 earth beads. People who become proficient in use of Soroban almost automatically become adept at mental calculation, known as Anzen in Japanese. As a part of Soroban instruction, intermediate students are asked to do calculation mentally by visualizing the Soroban and working out the problem without trying to figure out the answer beforehand. This is one reason why, despite the advent of handheld calculators, some parents send their children to private tutors to learn the Soroban. The Soroban is also the basis for 2 kinds of abacus developed for the use of blind people. One is the toggle-type abacus wherein flip switches are used instead of beads. The second is the Cranmer abacus, which has circular beads, longer rods, and a leather back cover so the beads do not slide around when in use. Brief history. The Soroban's physical resemblance is derived from the Suanpan, but the number of beads is identical to the Roman abacus, which had 4 beads below and 1 at the top. Most historians on the Soroban agree that it has its roots on the Suanpan's importation to Japan via the Korean peninsula around the 14th century. When the Suanpan first became native to Japan as the Soroban, it had 2 heavenly beads and 5 earth beads. But the Soroban was not widely used until the 17th century, although it was in use by Japanese merchants since its introduction. Once the Soroban became popularly known, several Japanese mathematicians, including Seiki Koa, studied it extensively. These studies became evident on the improvements on the Soroban itself and the operations used on it. In the construction of the Soroban itself, the number of beads had begun to decrease, especially at a time when the basis for Japanese currency was shifted from hexadecimal to decimal. In around 1850, 1 heavenly bead was removed from the Suanpan configuration of 2 heavenly beads and 5 earth beads. This new Japanese configuration existed concurrently with the Suanpan until the start of the Meiji era, after which the Suanpan fell completely out of use. In 1891, Irigaray further removed 1 earth bead, forming the modern configuration of 1 heavenly bead and 4 earth beads. This configuration was later reintroduced in 1930 and became popular in the 1940s. Also, when the Suanpan was imported to Japan, it came along with its division table. The method of using the table was called Kyukiho in Japanese, while the table itself was called the Hassan. The division table used along with the Suanpan was more popular because of the original hexadecimal configuration of Japanese currency, but because using the division table was complicated and it should be remembered along with the multiplication table, it soon fell out in 1935, with a so-called standard method replacing the use of the division table. This standard method of division, recommended today by the Japan Abacus Committee, was in fact an old method which used counting rods. First suggested by mathematician Momokawa Chubei in 1645, and therefore had to compete with the division table during the latter's heyday. Comparison with the electric calculator. On November 12, 1946, a contest was held in Tokyo between the Japanese Soroban, used by Kiyoshi Matsuzaki, and an electric calculator, operated by U.S. Army Private Thomas Nathan Wood. The Soroban won 4-1, with the electric calculator prevailing in multiplication. About the event, the Nippon Times newspaper reported that civilization tottered that day. While the Stars and Stripes newspaper described the Soroban's decisive victory as an event in which the machine age took a step backward, the breakdown of results is as follows. 5 additions problems for each heat, each problem consisting of 53 to 6-digit numbers. The Soroban won in 2 successive heats. 5 subtraction problems for each heat, each problem having 6 to 8-digit minuends and subtrahends. The Soroban won in the first and third heats. The second heat was a no contest. 5 multiplication problems, each problem having 5 to 12-digit factors. The calculator won in the first and third heats. The Soroban won on the second. 5 division problems, each problem having 5 to 12-digit dividends and divisors. The Soroban won in the first and third heats. The calculator won on the second. A composite problem which the Soroban answered correctly and won on this round. It consisted of an addition problem involving 36-digit numbers, 3 subtraction problems, each with 2 6-digit numbers, 3 multiplication problems, each with 2 figures containing a total of 5 to 12 digits, 3 division problems, each with 2 figures containing a total of 5 to 12 digits. Even with the improvement of technology involving calculators, this event has yet to be replicated officially.